Welcome everyone. This is Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Hello College of Commerce, University of Punjab, Lahore. Today is the 25th day on our online training session on Stata. We have covered uh, logistic regression, exact logistic regression, multinomial logistic regression, and order logistic regression in our four previous sessions. And today we are going to cover Probit logistic regression. So let me start the topic and let me also share the relevant data. But before sharing the relevant data, I would like to discuss the basics of Probit logistic regression and why do we use it and what is the difference between Probit logistic regression and the simple logistic regression and what is the basic specific detail about the Probit regression analysis. So here comes the topic, Probit regression. Probit regression is a type of regression analysis used to model binary outcomes. So we can say that it is similar to simple logistic regression or binary logistic regression, where the dependent variable can take only two possible values, usually coded as 0 and 1. So it is similar to binary logistic regression. The basic difference is that uh, it uses the cumulative distribution function, while the simple logistic regression basically uses the normality function or normal distribution function. So the basic difference lies between the usage of distribution function. So in case of Probit regression, it uses cumulative distribution function, while in case of logistic regression, it uses the normal distribution function as a standard normal distribution. So instead of logistic function to the model the relationship between predictors and the binary outcome. So you can say it is a non-parametric procedure towards the binary logistic regression. So whenever you are using uh, uh, Probit regression, it means you are not going to use the standard normal distribution. You are going to use the cumulative distribution function. So in Probit regression, the probability that the dependent variable equals 1, given a set of predictor is modeled as cumulative distribution function of a standard normal distribution. So it is an alternative to normal distribution here. So in simple terms, we can say that Probit regression, also called a Probit model, is used to model dichotomous or binary outcome variables in the Probit model. The inverse standard normal distribution of the probability is modeled as a linear combination of predictors. So this is the technical difference. You are going to use the inverse standard normal distribution function here. While the remaining things are similar to your binary logistic regression. So let us discuss some examples in order to understand this particular topic. For example, let's say we want to predict whether a student will pass or fail. For pass, we can code it as a 1, and for fail, we may code it at 0. So we want to predict whether a student will pass or fail an exam based on the number of hours they study, that is your first independent variable, their previous exam score, that is your second independent variable, and whether they attended a preparatory course, that is your third independent variable. So on the basis of three independent variable, we are going to predict whether a student is going to pass or fail exam. So we can use Probit regression to model this relationship. Once the model is estimated, we can interpret the coefficient to understand the impact of each predictor on probability of passing the exam. For example, a positive coefficient for the number of hours studied would indicate that studying more hours increases the probability of passing the exam. There are two more examples that we need to understand. And one of these example we are going to discuss as a practical data example. So I will share the data set with you. So example one is suppose that we are interested in the factor that influence whether a political candidate wins an election. So the dependent variable is binary. If he's going to win the exam, it is coded by 1. And if he is going to lose the exam, if he is going to lose the election, it is coded by 0. So 0 mean lose, 1 mean win. So the predictor variable of interest are the amount of money spent on the campaign. That is your first independent variable. The amount of time spent campaigning negatively, it is your second independent variable. And whether the candidate is an incumbent, which means he's already holding some political office. So you can say this is the independent variable third. So we are going to base your prediction on the basis of these three independent variables. The second example that we are going to discuss here, and on the basis of it, we will consider the execution of Probit regression using some data here is a researcher is interested in how variables such as GRE, which is graduate record exam score, GPA, that is grade point average, and prestige of the undergraduate institution affect admission into graduate school. So we are going to consider whether a student is going to get admission into a graduate school on the basis of his or her GRE score, his or her GPA, and the prestige of the institution, whether it is high ranked institution or whether it is low ranked institution. So the response variable would be admit or don't admit. It is a binary variable. So on the basis of it, we are going to discuss some data. So let me share the data set, although this data set we have used previously, but for your convenience, I am going to use the data set again. So I am going to share the data set for this example so that you may be able to execute it for your convenience. So let me share the Probit regression example 2 dataset. So for today's session, we are going to discuss this dataset. So let me open this file directly for our convenience. Let me open this data first. And then we are going to open our data set, example 2 data set from Probit. Yes. So this data set contains 4 variables. The first one is admit. The second one is graduate record examination score. The third one is GPA, and the fourth one is the ranking of the institute. So there are 4 variables. So here is the description of these variables. So we need to understand the particular description here. So this data set has a binary response or outcome or dependent variable called the admit. There are 3 independent variables like GRE, GPA, and rank. We will treat the variable GRE and GPA as a continuous variable because they contain some score. The variable rank is ordinal. It takes on the value of 1 through 4. Institution with rank of 1 have the highest prestige, while those with the rank of 4 have the lowest prestige. So we will treat rank as a categorical variable. So first of all, we need to summarize our data. So we need to consider some command with GRE and GPA in order to check the data. So write sum and put here GRE and GPA, and it will show you the summary of this data set. So you are seeing that there are 400 observation with this data. The average GRE score is 587.7. The minimum GRE score is 220, while the maximum GRE score is 800. The GPA is the average GPA is 3.39 and minimum GPA is 2.26 while the highest GPA is 4. So this is the basic detail of the GRE and GPA. Then we are going to see the rank, which is a categorical variable. So tab rank, enter, and it will show you those with the highest prestige institutions have 41 applicants. Those with the second highest category institutions have 151 candidates. Those with the uh, second last category of institution have 121 candidates, and those with the least ranking institutes have 67 candidates here that are going that have been considered for apply here. So what we need to do, we need to see the admit and then admit and rank. So we need to see. So these are basically the number of institutions. Highest institution are 61, 151 are second highest institution, then third highest institution, and the least one is 67. So we are going to see the admit score here, tab, admit. So we can see here 273 students could not get the admission, while 127 students got the admission. So if we need to see tab, admit, and rank. So we can see here that 28 students could not get admission in the highest ranked institutes, while 33 students could be able to get admission into highest ranked institutions. In the same way, 90 students, 97 students are were not able to get admission into the second ranked institutions, while 54 students were able to get admission into the second ranked institution. 93 students were not able to get admission into the third ranked institution, while 28 students were able to get admission into the third ranked institution. 55 students were not able to get admission into the fourth ranked institution, while 12 students were able to get admission into the fourth ranked institution. So after doing this, you are able to analyze your data using Probit logistic regression. And before doing that, we need to understand some basic things here in order to perfectly apply the procedure. For example, we use the Probit command to estimate a Probit regression model. The I before rank indicates the rank is a factor variable and that it should be included in the model as a series of indicator variables. So you just need to write here Probit, and then you need to put your dependent variable, and then you need to put your independent variable. So if we do not consider I before the categorical variable, so let's see what would be the result. So it will show you the result. The model is statistically fit. The R square is approximately 8.1%. You are seeing that GRE is positively impacting your admission score. Then GPA is also positively impacting your admission score, while the rank is negatively impacting the admission score. But if we put the I before this categorical variable, what will happen here? So put I dot before rank and see the results. What actually is shown you as a result. The GRE and GPA are showing the similar results as we have seen before. In this case, they are giving the similar results with the uh, with the you can say little change in p-value, while you can see a detailed analysis of the rank score. The first rank of the institutions are considered here as a reference category. So we need to interpret these values, how these values are interpreted here. So let me discuss it. The likelihood ratio, which is chi-square, is 41.56 with a p-value of 0.000, tells us that our model as a whole is statistically significant, so that it fits significantly better than a model with zero predictor. So in the table, we see the coefficient, their standard error, the z-statistic, the associated p-values, and the 95% confidence interval of the coefficient. Both GRE and GPA and their indicator variable for rank are statistically significant. We have seen the results. All variable or independent variables are statistically significant. The difference is basically with their sign. You have observed that GRE and GPA are indicating positive signs, while the rank is indicating the negative sign. So we need to be very careful about their interpretation. So here comes the further interpretation. The Probit regression coefficient gives the change in the z-score or Probit index for a 1 unit change in the predictor. So for a 1 unit increase in GRE, the z-score increases by 0.001. For each 1 unit increase in GPA, the z-score increases by 0.478. So you can see here the values. These are the coefficient values like this. So it is interpreted here like this. So we can say that if a 1 unit is increase in GRE or GPA, there might be an increase in the admission score or admission chances in case of GRE by 0.001 and in case of GPA 0.478. So the indicator variables for rank have a slightly different interpretation because the first category of rank score is considered as a reference category. So here we can say, for example, having attended an undergraduate institution of rank 2 versus an institution with rank 1, it decreases your admission chances by 0.415. So here, if you can see, this is the coefficient value of your second rank institution. So you need to compare this with your reference category, which is first rank institution. So as compared to first rank institution, if you got admission into second rank institution, it will decrease your chances of admission by 0.4153. In the same way, if you try to get admission into the third rank institution as compared to first rank institution, it will decrease your chances of getting their admission there by 0.8121. In the same way, if you try to consider the fourth rank institution for getting admission, for getting your undergraduate admission as compared to the first rank institution, it will decrease your chances of admission by 0.9358. So this is how you can interpret your variable prominently. So we can consider the other aspects, like for example, this is the other aspect, that is the margin command. So we use the margin command to calculate the predicted probability of admission at each level of rank. We are not going to consider here the odd ratios because in case of Probit model, we just need to interpret the coefficient results only. So we don't need to consider here the odd ratio. But if we are interested to consider the logistic regression or binary logistic regression, then we need to consider the odd ratios after our simple model. So here, in case of Probit model, you don't need to consider the odd ratio, but you can consider the margins command. So we use the margins command to calculate the predicted probability of admission at each level of rank. So what is the probability of admission at each level of rank, holding all other variables at their means? So first of all, we need to consider this command because rank is an ordinal variable here. So we can consider this command. So you can see here, these are basically the probability of admission um, using the ranking of the institution. So there are 51.63% chances of admission using the first rank institution. There are 35.40% chances. There are 22.03% chances. There are 18.54% chances of getting admission. If you consider the rankings of the institutions here. So this is the proper interpretation. In the above output, we see that the predicted probability of being accepted into graduate program is 0.52 for the highest prestige undergraduate institution and 0.19 for the lowest ranked institution holding GRE and GPA at their means. So this is how you can interpret your margin ranking. So uh, the next thing is if we make some conditional estimates on the basis of some results, like if we consider GRE on the basis of their score, and we will consider the margin account on the basis of it, we can also predict it. So below we generate the predicted probabilities for value of GRE from 200 to 800 in increment of 100 because we have not specified either at means or use at to specify values at which the other predictor variable are held. So the values in the table are average predicted probabilities calculated using the sample values of other predictor variable. For example, to calculate the average predicted probability when GRE is equal to 200, the predicted probability was calculated for each case using the case value of rank and GPA and setting GRE 200. So this is the conditional estimations. If you are interested to find out whether on the basis of this and this GRE score, what would be our predictions? So you can see here, these are the different GRE scores. This is first, this is second, this is third, this is fourth, fifth, and seventh. And here, these are located here. So if we consider the GRE score 200, so there are 16.21% chances of getting admission for your undergraduate program. If you got the GRE score equal to 300, you have 19% chances of getting admission into an undergraduate program. If you got GRE score of 400, you have 23.30% chance of getting admission into that particular institution. If you have GRE score equal to 500, you have 27.41% chance, and all these values are significant. If you have 600 score, you have 31.85% chance. If you have 700 score, you have 36.58% chance of getting admission into an undergraduate program. And if you have 800 score, you have 41.51% chance of getting admission into an undergraduate program. So this is how you can consider different conditions on the basis of your scores. So here, in case of this command, if you can see here, GRE is the conditional variable, 200 is the starting point, and this bracket 100 basically indicates the gap and the 800 is the last limit. So you need to consider that you want to start from 200, and with the gap of 100, you can produce different results up to 800. So this is the last limit, this is the starting point, and this is the plus 100 gap that will be added between your each estimation. In the same way, this is the last thing that we need to consider here. In the table above, we can see that the mean predicted probability of being accepted is only 0.16 if the GRE score is 200 and increases to 0.42 if one GRE score is 800. So if your GRE score increases, your chances of being acceptance or admission into a particular institute or undergraduate school is basically increases. The last thing that you can consider here is the fit stat. So you can calculate the fit stat here. That is the detailed table, fit stat. So it will show you the different values like McFadden's R square, maximum likelihood R square, McCalvey and Jovina's R square, variance of Y, count R square, AIC criteria, BIC criteria, your log ratio that shows the statistical significance of your model and so on. So this is the additional statistic that you can generate and you can report in your estimation. So this is the end of basically the topic, that is regression with categorical dependent variable. So after this session, we will start from tomorrow the time series regression analysis. So, dear participant, do you have any question? Mohammed Bakar, do you have any question about today's topic? Please let me know if you have any question.
No, sir.
All right, so let's conclude this session. We will consider this time series analysis as a final part from tomorrow in order to consider the end of the training sessions in the upcoming 3 or 4 days. So thank you very much for joining and stay blessed, and let's see you tomorrow.